Welcome back, Year 10. So moving on from yesterday and forces and their interactions, we're moving on to resultant forces. So once the two forces have interacted, what is the overall effect of that force, that interaction? So learning outcomes for today, we're going to understand what is meant by a resultant force and calculate the resultant forces and use free body diagrams to calculate the resultant force. So it would be really good at this point, if you haven't already done so, make sure you've got a ruler and a pencil, because you're going to need some of that sort of gear, as it were, to be drawing this. Otherwise, just use the side of your phone and your biro, whatever's going on in your lives at the moment. Go for it. So, quick quiz, 1 to 10 in the margin for me. Pause the slide, answer the following 10 questions. So, here's the answers. True or false, a vector quantity has both magnitude and direction. There's that word there, both. So, it's true. And what is the minimum number of forces acting to produce friction? It has to be 2. What type of energy is dissipated due to friction? Dissipated means given out, all right? For those of you who are thinking, what is she on about now? Then, number 4, a boy walks from school reception 200 metres to the dining hall, then returns to the same spot in reception. What is his displacement? 0. Because actually he hasn't actually travelled it's the distance that he's travelled from his origin. It's not the distance he's travelled, but it's his displacement from his origin. Then, speed, distance, time, and velocity are all scalar quantities. Velocity is a vector, remember, because it has both magnitude and direction. In fact, the definition of velocity, for those of you out there that are really interested, is speed in a given direction. Weight is a vector quantity. What is the equation for weight? Weight equals gravitational field strength times mass. Remember, we can rearrange that into a lovely equation triangle. A bit more about that later. Random one here. Biology revision. In which organelle does photosynthesis take place? Chloroplast. Hopefully you've all got that right. And then number 8, a hammer hits a nail, downward force of 50 newtons. What is the size and direction of the force on the nail on the hammer? Well, it's got to be 50 newtons. And again, what's that piece of equipment that we use to measure forces? It's a Newton meter. All right. If we're ever unsure about what the name of the piece of equipment is, and it's a measuring piece of equipment, we're going to take an educated guess and use the word meter and add an associated word at the front. We don't leave anything blank, guys, because you can do it. Chemistry revision. A metal ion is positive or negative. And what is the general name for this type of ion? Oh, sorry. Completely misread that one. Is a metal ion positive or negative? It's positive cation. Okay? So, I always remember it that cations are positive, like pussycat. Anyway, let's move on. So, I'm calculating a force. The equation for today, which we're all going to love, is force equals mass times acceleration. And forces can be contact or non-contact forces, and we talked about that yesterday. And forces are measured in newtons. They're the 3 bits of information that we're going to need to hold on to whilst moving forward. 1 newton of force is the force needed to accelerate 1 kilogram by 1 meters per second. I suggest you write that piece of information down, especially for those of you doing higher and triple, because that piece of information is what we call assumed information. They expect you to hold on to it and apply it in those hard questions. So if it was me and I was feeling like I really want to get my 5, 6, 7, 8 and 9, I would be writing that down, putting a box around it, making sure that I remember that fact. So, calculating force. The man has a mass of 85 kilograms and the gravitational field strength is 9.8 newtons per kilogram. Calculate the weight of the man. So we do 85 times 9.8 gives me a weight of 833. All right. Now, 40 to 50% of the physics paper will be just your ability to apply the equation sheet that you're given and do the maths. And some of the questions are worth 5 marks just for being able to apply a number of stages to maths. So make sure that these papers that you A, have a good ruler, B, have a pencil, and C, have a calculator that you know how to use. All right, and make sure you do some revision. So let's look at the next question. A woman uses a bar to do a pull-up, and the woman has a mass of 62 kilograms. She accelerates at 11 meters per second. Calculate the resultant force on the woman. We're going to use the equation force equals mass times acceleration. So our mass of 62 times 11 gives me a force of 682. I think that's really easy marks. It's just timesing two numbers together. Please, please, please make sure you use a calculator, okay? Some people I mark quite regularly, and some people sit there and are trying to do this. If in an exam you've forgotten your calculator, put your hand up, harass an invigilator. They're probably bored looking for something to do. But there is a whole stack of them at the front that Mrs. Thornwell is only too eager to lend out to ensure you do your best. Ooh. Okay, these are the points that they want you to know. Make sure you've written those down. So, applying Newton's first law, okay, unbalanced forces. Got my tug of war going on here. So the resultant force is 0 because there will be no movement. There's 300 newtons in one direction, 300 newtons in the other. Everybody stays the same. However, if on the team on the left, we've got somebody who's clearly had their Weetabix and a load of Red Bull, they are going to be able to apply a greater force than the people on the right. Therefore, the team on the left are pulling with 400 newtons. The people on the right have only got 300 newtons. There is a resultant force of 100 newtons moving to the left. Okay? Make sure that you give the size and the direction. It's really important. Sometimes it'll ask you to add the force to a diagram. You just draw an arrow above the 400 and you just put 100 newtons with the arrow. Perfectly fine. So, we've got this camel standing on a road. An attractive camel it is. So, what forces are acting on this camel? Now, you've been doing these sorts of diagrams in year 7 and year 8, and you're probably thinking, what is the point? However, they're just seeing what information you can drag through and that you've held on, and that assumed knowledge. So, we've got weight, and we know that weight is made up of gravitational field strength and mass. Okay? We've got the reaction of the road. We know that there's a reaction of the road because the camel is not sinking into the road. If the reaction was smaller than the road, then the camel would be sinking, as if it was in mud or quicksand. Okay? Because these two forces are balanced, the resultant force is 0, and we say that actually there is no reaction. The camel doesn't move anywhere. It's not floating in the air, and it's not sinking into the ground. But if we took the road away, the camel would disappear. There would be no reaction. Now, we've all had this where you stood on soft ground and you felt yourself sinking. That is because the reaction is not equal and opposite to your weight. Okay? And this is Newton's first law of motion. That unbalanced force causes the acceleration of the force downwards. So, scientists, physicists love using diagrams to represent different ideas. So we've got our fast car here. Not sure what it is. It's blue. So, first of all, we've got an arrow moving forward. Now, that arrow is going to be my thrust force. And that is the thrust of the engine that is pushing my car forward. And that has a capacity of 1,000 newtons. We don't measure in anything other than newtons. So remember, all force arrows have to be start at the centre of gravity. In this case, it's going to be in the middle of my car. And it's a nice spinny label there for you. Force is a vector quantity, so the arrow always shows the direction of the force and which direction it's acting in. Now think about this really carefully. Is force the only force is thrust the only force acting on this car? Quite simply, no. There has to be a reaction between the tyres and the road. There has to be weight and there has to be air resistance. So they have all got to be added and they're all acting in different directions. So weight is acting downwards, reaction is acting upwards, and air resistance is pushing back on the car. Calculating a resultant force. So here's my fighter jet. Okay, what is the resultant force and in which direction? So we've got a motive force of 2,000 newtons, which is my thrust. Okay, air resistance, which is 500 newtons. So therefore, the resultant force is 2,000 take away 500 gives me 500 newtons to the right, which you can sort of be seen by the fact that the arrow to the right is larger. Okay, it shows me it's bigger. It shows me that it is a larger force because it's a larger arrow. Now you can have a go at doing a couple on your own. Don't forget about the size and the direction. So we've got a number of different activities for you to do here. Pause it and literally on your smiley faces, okay, or literally number them 1 to 10, tell me which direction is and the size of the resultant force. Brilliant. So, number 1, the resultant force is 1 Newton going upwards. Okay. Number 2, there is no 0 resultant force because they're equal and opposite. Number 3, 10 newtons to the right. Number 4, 15 newtons to the left. Number 5, 30 newtons upwards. Again, equal and opposite. Number 7, nearly lost it there, 15 newtons to the left. Number 8, 2 newtons to the, oh no, she's written left, but it's not left. It's to the, it's no, so it's 2 newtons to the left, so yeah, ignore me. Right, then it's 2 newtons upwards, and lastly, okay, we've got 4 different resultant different forces acting on here. However, the overall force is 10 newtons to the left. Okay, how did you do? So give yourself a score of 1 out of 10. So it's really important that we understand that what happens, the effect of the resultant force equaling 0 and the effect of the resultant force being different to 0. Okay, so can we copy out this table so that you've got it? So if it equals 0, something stays either at constant speed, it stays stationary, okay, it doesn't move, it stays moving in a constant speed in the same direction, everything about it stays the same. If it doesn't equal 0, we talk about it accelerating, it getting faster, okay? Or it could cause a change of direction of our object, or it could cause what we call retardation, which means slowing, okay, of our object as well. And as we've put here, a little tip for you, lots of people get really confused, especially with the pressure of exams. They say, oh, well, if the resultant force is 0, then the object must be stationary, it cannot be moving. But you need to remember that something that's got a resultant force of 0 can be moving at a constant speed in the same direction. All right. So free body diagrams. Okay. So these show me relative magnitude and direction of forces acting on an object. Okay. They can be used to calculate the resultant force, and the length of the arrow must be drawn to scale. Okay, and that will help you calculate what you're doing. So you haven't got a ruler, go and raid a cupboard and make sure you've got one. The arrow head represents the direction in which the force is acting, and the dot or the box usually represents the object. So here I've got is my box on a shelf. The shelf is slipping, and therefore there is going to be a resultant force. There will come to a point where the shelf tilts enough that the box will then move. So the box itself has got weight, and as we know that weight is always going to be in the direction of gravitational field strength. There is going to be friction between the bottom surface of the box and the shelf, and there is going to be a reaction force of 8.7 newtons pushing up from the shelf onto the box. So the diagram on the left is what's going on, and the diagram on the right is my free body diagram. You can see that my arrows are different lengths depending on what they're representing. Choose yourself a nice sensible scale. Don't go all crazy. Make it as easy as possible to do. So just use, I don't know, 1 Newton equals 1 centimetre. That's all they really want to see. So, free body diagrams. Draw a free body diagram to represent the box sitting on the table. There is a 0.2 newtons of weight and a reaction force of 0.2 against each other. So that's all we're going to do. It is that simple. Okay. Now, draw a free body diagram to represent a stationary duck sitting in a lake. Okay. Duck has a mass of 1 kilogram. You need to ask yourself 3 questions. Firstly, what are my forces acting on my duck? Okay. What direction are they acting in, and what are the sizes of these forces? Now, this is a bit like the maths questions where they say, how high is the man if the tree is 6 meters? Well, the duck isn't going to be weighing loads, but they need to give you a sensible amount. A good amount for a duck's about 5 kilograms, all right? So, number 1, forces acting on gravity and upthrust. So, the weight acting downwards and the upthrust acting up. Now, as long as you put about 10 kilograms, 10 newtons down, 10 newtons up, be fine, okay? This is a very small duck. Obviously, I haven't weighed any ducks lately. So, weight of my duck is 1 kilogram, and I times that by 9.8, which gives me 9.8 newtons. Awesome. And my free body diagram would look like this. Even better. So, the key points from today's lesson is the resultant force is a single force. You can all read, pause this, make sure you've written down these key points. Now, to test how much you've understood, what we're going to do is I'm going to ask you to now go on Sam Learning and do a quiz for me, because I love a Sam Learning quiz and they're my favourite things in the world. Okay, guys, stay safe and I will see you tomorrow.